Saturday and got it all set up, ready for class. It's ready to go here, and it wouldn't come on today. It's completely dead, fried, and I have to take it back. So now I'm having to work off of a totally different setup, which is unfortunate, but make it work, okay? All right, welcome everyone. Y'all doing all right? Y'all ready for this? It's good to see all of y'all in person. And Desiree, it's nice to have you here too. So we have, I think, one student. Let me see if there's anyone else. You look like you're the only one. Make sure. I just want to make sure that the meeting is not locked or something. Oh no. Okay, we've got another. Yeah. Okay, so I know some of you already had asked about the solutions for the video solutions for the homework for 3.1, and I had started doing those, and I think I got through some of them, and I didn't finish them all. I did post some of them though. Did y'all see that? Okay, so I'm going to work on it, but I'll be honest with you. Now that my laptop, my brand new $1,800 laptop, dead, I have to go take care of this first because I need this for next week, so I'll be spending a lot of time doing that. And when I get it done, I'll get the videos going for the homework solutions. Are there any questions over anything? We're supposed to have an exam, right? When is our first exam? Let me get logged in here so we can just take a quick look. See, I can't even bring up like all my notes and everything. They were on my other laptop, so I'm going to have to go in through here. Let me see. Schedule. Course schedule. Here we go. So our first exam is scheduled for September 22nd, right? So today is the 8th. We're supposed to be starting 3.3. We're actually going to be doing 3.2 today. So graph of a function today. So we're behind. That's supposed to be here. So we'll just see how it goes. But we've got some time before our next test, and that will be what? Oh, 2 weeks from today. All right, is scheduled our first test, and the idea is that everyone will be physically here for the test. All right, I'm going to continue to do this Zoom thing, at least for a while. I don't know if the college is going to get mad at me for it because I'm supposed to have y'all here because you signed up to be here. But I think it's just, this will be a good option to have just in case, all right? Now, regardless, if I do stop doing Zoom, I will record all my lectures, okay, and I'll post those on YouTube later. So I'm recording in two ways. I'm recording off the camera, which will be higher quality, 1080p, and then whatever Zoom's putting out there, that's another, you know, I'll have both videos. I'll put the better of the two up. Any questions? We're going to get into 3.2, graphing functions.
So I have a question.
Yes?
What is the exam covering?
It should be everything that was on that schedule up to, well, it's going to depend on where we stop, okay, because we're a day behind. But it's supposed to go all the way up through quadratic inequalities. We'll see, okay, because we only have today, and then we have next Monday and next Wednesday. Right, and then the following Monday. So we have 4 days before our test, 4 class periods. So let's just see how we do. We'll know when we get closer, all right, what's going to be on the exam. All right, so we are going to start this section, and I'm going to be working out of the ebook here. And normally what I do in a regular class is I usually project the notes like this. I'm recording. I'm going to pretty much contain myself to this screen, so it's all recorded. I need them to move the projector down a little bit so that I can write on the screen and put the notes back and forth, like bring up the notes, then a blank screen, I write on the board. You'll see as I try and do this right now. But today, can't move it. So, all right, so we're going to talk about graphs of a function. The main objectives are to identify the graph of a function and then obtain information about the graph of a function. So this section I think you're going to find to be a lot easier than like the difference quotient stuff we were doing, all right? So we have all heard of this thing called the vertical line test before? Yes, vertical line test. So the vertical line test, I think what I'm going to do here is, where's my thing? Turn this off. There we go. So the vertical line test works as follows. You have, if you sketch a relationship between two variables x and y, there's all different sorts of ways that we can draw them. Right? So like here's an example. So when we talk about the graph of a function, what we mean are all the points which satisfy some relationship. So let us look at an example. Are you okay there? You want me to pull this back a little bit? You sure? Okay. That satisfies some relationship. So let me give you a relationship up here. If I tell you, as an example, we have this relationship that y equals 2x, right? Y is equal to 2x. Then you can start coming up with different x's and different y's that would satisfy this. So for example, we like to do t-tables. Remember t-tables? X, y. If I just start plugging in values for x, 1, we can start getting values for y. 2, 4, 3, 6, right? So just replace x with these values. These are your y values. All of these can be visualized as points on a graph. And so if I start plotting these on an xy plane, then putting all the dots together, you will get the graph of a function, or the graph of a function. It's any points that satisfy some relationship, all right? So I think all of you are familiar with that idea. But to be a function is a very, very strong condition. It means that if you have one input, you can only have one output. And we talked about this again last time when I was drawing the domains and showing arrows going. So visually what that means is this. If we have, like here, 1 goes to 2, right? We can't have 1 go to 2 different places. So we couldn't have this. I'll do it in a different color. This would be bad if we had 1, 4. That means 1 goes to 2 and 1 goes to 4. What would that look like in a picture, though, if we had this scenario? So I'm gonna show you right here. So let's say we had that 1 went to 2. So we put that point, and then we have this one, 1 went to 4. You have another point, right? Now if I plot all these other 2, 4, 3, 6, that's going to draw a line like this. So when you have a function, this can't happen, right? And the way we can check visually is by running this thing called the vertical line test. So the vertical line test says when you're looking at the graph of something, if you draw any line that hits the graph more than one, any vertical line, if it hits it in more than one place, then it is no longer a function. Have y'all heard of that before? I think most of you have. So like right here, if I start drawing vertical lines, I'm only hitting once, right? Once, 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 once. But if I try and go right here, that's where I hit twice, right? And that would violate what it means to be a function. So that's the spirit of the vertical line test, is just looking to see if you ever hit more than one time when you draw vertical lines. So let me give you some examples, and then you can tell me whether or not the graphs that I put up here represent functions or not. So go back to this one. We'll just go around the room. What's your name? Sorry, I tried my best with the online to learn names, but it's still hard. What's your name?
Tavi.
Tavi, okay. Is that a function or not?
No.
No? Okay, so why?
Because the x values repeat. If you draw a horizontal line.
Okay, horizontal line. Okay, so if I draw a horizontal line, it will hit more than one spot. I agree with that, right? To test for a function, right? For a function, if you want to know if it's a function, you do the vertical line test, which means we're only looking at vertical lines. I agree with you. If I draw a horizontal line, I'm going to hit more than one time. But what about vertical lines? Because for functions, I'm only looking at vertical.
Oh, you would only hit it once.
I would only hit it once, no matter where I do it, right? So would this be a function? Yes, right? Everyone got that? This would be a function. So in this particular case, yes. I agree with the horizontal, and we'll get to that, just not yet. Okay, let's do another example. Tavi, right? That was Tavi?
Yeah.
Okay, good. All right, you're up. You ready? What's your name?
Carissa.
Carissa?
Yes.
Okay. All right, Carissa, let's just change it up a little bit. Is that a function?
No.
No. Okay, why?
Because it crosses the same point
Twice. In a couple of places, right? So if I do this, it only hits once, right? This only once. But if I can find anywhere where it hits more than once, it's no longer a function. So like right here, right? Hits 3 times. So this would fail to be a function, yes? So no, not a function, right? Not a function. Okay, next. How about this one? Go ahead. No? What about if I draw, what was your name? Michelle. Michelle, okay. Here, doesn't hit at all, right? If it doesn't hit at all, it's okay. You just can't hit more than one time, all right? If I draw this one right here, it hits right there, just that single point, that's okay, right? But anything in here, right, I hit more than one time. So again, this would be no. Students usually love the vertical line test because it's not a difficult concept to understand visually. Would you all agree with that? You would probably prefer if your test just had like 100 of these problems and that would be it, and you just move on, right? Okay, so we move on. The vertical line test is the first thing that we do to check whether or not something is a function. Now, Tavi brought up the horizontal line and that it hit more than once, right? Okay, do you know what that's test? Does anyone know what that test is for? It's not to test if it's a function, it's to test something else. Does anyone know? It is a test, but it's not the test for function. No? It's okay if you don't. I mean, we'll learn it later this semester. That's what we use to test whether or not the function has an inverse. Okay, which we will talk about that again later. Oh, where's my mouse? Okay. I think I've decided not to project the notes because I don't like the contrast that I have with the bright light and the dark board. All right, so let me give you an example here, and see if you can interpret a graph. If I give you the graph of something, can you interpret it? So don't spend too much time trying to copy this down and make it like exactly the same. But let me do this. Okay, so I'm gonna label this. So this is 4, -4. Let's make this 2. Let's make this -2. Okay, so looking at this, all right, I have some questions for you. I want to see if you understand by looking at a graph how you can read things off of it. right? So my first question, and we're moving on to
Ugo.
Will?
Ugo.
Ugo?
Yeah.
Okay, all right, so you get the first one. Let's say that this is the function f. It is a function, right?
Yeah.
Pass the vertical line test. Okay, so let me ask you this. What does it look like f of negative 4 is to you?
The 0.
0, right? So going to negative 4, 1, 2, 3, 4, negative 4, looking for that point right there. The x value is negative 4, the y value would be 0. Everyone agree with that? So this would be 0. This is like the x, and this is like the y, right? Y'all agree? Okay, let's move on. Amanda? Okay. So Amanda, let me ask you this. Can you tell me what f of 1 is? 0, again, right? That was this point right here. F of 1 was 0. Okay. How about this one? This one's going to be harder. Josiah, that's right. Okay, Josiah. Okay, so this one's going to be harder. I would like to know, Josiah, sorry, 2. What is x? Now this is a harder one. So can you kind of tell me what you're thinking here when you see this?
To go in between points on graph. -2.
Negative 2. So this 2 means what? You're looking at what on the graph?
2 up.
Okay, so you're looking for where, so here it was plug in this value of x and then give me the y, right? Here, this is saying, hey, here's the y, right? Tell me what x gives you that y. So Josiah is saying, okay, here's 2. So it looks like, I don't know, somewhere around here-ish, somewhere in there, about there. So now what x coordinate corresponds to that? Now look, my graph kind of sucks, but on a test and on your homework, it'll be easy for you to see where things are. But it looks like, I don't know if I kind of cheat a little bit, maybe it's about right there, right? The important thing was interpreting it correctly. In other words, this is the y coordinate that's given, and we're looking for the x. So I would say x is -2. Yeah? Okay, next question. Let's see. Adam? Okay, Adam, I have a harder one for you. All right, you ready? Where is f of x positive? So just kind of tell me what you're thinking here. Like, what is your interpretation of that?
So I will find all the points in between that are over the x-axis.
Over meaning over is in above?
Yes.
Okay. So can you tell from here, you're saying where are the points on this function above the x-axis, right? Which occurs all over here, right, in this region? So this is saying where is the y, right? Where are the y values? Where are the y values positive? And you're supposed to tell me for what x values you get positive y values. So can you tell from there where you're going to get positive y values from?
-4.
From -4
1.
all the way to 1, right? Any x value between -4 and 1 will spit out a y value that's positive. Now, do I include -4?
Yes.
We want it strictly positive. So if you plugged in -4, didn't we say earlier -4 would give you 0? Right? 0 is not a positive number, right? So we don't want to include -4. We also don't want to include 1. That makes sense? So we would say everything between -4 and 1. And the way we write that is -4, 1, right? Everything between -4 and 1. And these are x values, right? These are x's. In math, we use this little symbol. It's an E. It's like an E that's sideways. It means x is an element of this set. So that would be where it's positive. Good? Any questions? Let me see. Desiree, is this coming out on camera or is it legible enough?
Yeah, I can read it.
Okay. All right. Let's do the next one. E. I'm going to make one up here. So how about this one for E? And who's up? Sir?
Josiah.
Josiah. Okay. So don't we have two Josiahs, right? Y'all are at the same table. It's going to, I'll be okay. Y'all going to be okay? Yeah? Okay. So where, Josiah, number 2, what's your last name?
Reynolds.
Reynolds? Okay. So where is the function negative? So tell me what you're thinking there.
I'm looking at it. All our values are negative, either past -4.
Okay, like over here.
Yeah. Or between 1 and 4.
Right, between 1 and 4. Would you all agree between 1 and 4 for sure?
Yes.
Now this is a little sketchy because I didn't really give you enough information. I put a dot here, right? When you see a dot, that means the function stops there. If I put an arrow, it means it keeps going. So I need to maybe throw a little more information in here. How about this, Josiah? How about I put that there? Does that kind of help? You can kind of tell that between -5 and -4, your graph is below the x-axis. And then between, you said 1 and 4?
Yes.
So how would I write that in like this sort of format?
I have no clue how to involve the between the -5 and the 4. As far as the 1 and the 4, we would do the 1, 4 in parentheses because you're not including that.
Okay, yep. Good. That's the same thing for over here because you want to go from -5 to -4, right?
Yeah.
So same thing. -5 to -4 in parentheses. Everything. Now we put the two together with the union. So it's those sets of x values along with these sets of x values. So the important thing again, I guess, to remember or to understand from this is that what this represents is all the different values that you can plug in for x that would result in a negative value of the function. So if I put any number between 1 and 4 in, I'm going to get a negative output. If I put any number between -5 and -4 in, I'm going to get a negative output. And then if I go -4 to 1, I'm going to get a positive output. All right. Any questions?
I'm confused.
Okay. So give me a number between 1 and 4. 2. Okay, so if I go to 2, here's 2, right? If I go out to 2 and I plug into the function, here's the function, right? I've got to go down. So this point is the point 2, and then would you agree that this number, because I had to come down, would you agree that number is negative? I don't know what it is necessarily, but it's a negative number, right? And for any number that you were to pick between 1 and 4, you're going to have to go down, right? Which means you have a negative output. And that's what this is asking. Where are you getting negative outputs for the function? And it always happens between 1 and 4, and then also between -5 and -4 because you'd have to go down. Does that make more sense? And then this one was the other thing. It was between -4 and 1, it goes up, right? Okay, so this, now you're up. What's your name? Lisana. Okay, so this one, where is f of x not positive, not negative, but where is it 0? So I've kind of indirectly already asked this question, but I want you to kind of think through it and tell me what you...
So it would be anywhere where it directly hits the
That's right. Okay, so can you tell me where that is? -4, it happens here. 1 and 4, right? Those 3 places. Now the reason I'm giving you this is because the previous 2 answers were intervals, weren't they? How do we represent an answer that contains multiple points in it? Right? How do we do that? You said it was at -4, at 1, and at 4. So the way we do that is this. We don't use parentheses, we use braces. The braces tell you this is a set of numbers as opposed to an interval of numbers. And then you just list out the numbers with commas between them. -4, 1, 4, close the brace. 3 places where it happens. Does that make sense, everyone? Yes?
Just to double check for the x values, we would use the little e whenever we input, when parentheses are all just x values, correct?
I'm not sure what you're asking. Say again?
Like, so like for the parentheses, without like symbols, it would just be -4, 1, which is like an x and y. But whenever you put the e, that's all x, right?
So you brought up a very good point. Okay, this is one of the places in math where our notation just sucks. Okay, it just sucks. Because in general, if I were to write down, let me do it over here. If I were to write down -1, 4, okay? Let's say you walk into the class today and I wrote that down on the board. And I said, what is that, right? You're not going to know the correct answer because you don't know the context in which I'm using that. On one hand, you may think it means the interval, -4 to 1, all the numbers in between, not including the 2 endpoints. That's if that's an interval. But you could also look at it as a point, 1, 2, 3, 4, to the left 4, and up 1. That's the point for -4, 1, right? Those are 2 different things. So it's kind of like this is a cat, that's a dog. I mean, they're different, right? And that, unfortunately, in our notation, you can't distinguish between the 2. So you have to understand the context in which it's being used. So when this is asking where is it all positive, this would represent an interval, okay? If it were a single value, like a point, we wouldn't do this. We would just say -4. At -4, that's where you get a positive value, if I wanted to specify a point. So that's why throwing the x as an element of this, that is what would actually tell you that this is an interval. So this notation is not normally used. I mean, it is later. Mathematicians use this because we do need to distinguish between the 2. I'm not going to be a big, I'll understand what you mean if you put this. Am I answering your question, addressing your concern? It's a good question. It's just, there's other places in our mathematical system where our notation is just bad. And if we could redo it again, we should probably have done something else. But it's the convention, it's what we use, and it is what it is. Okay, I want to continue. You ready for some more? Same picture. EF, here we go, G. All right, where are we at? You want to go, sir? What's your name? Juan. Okay, go ahead, Juan. You can see that? So what does this mean? The domain of F. Okay, the domain of F. So what does that mean to you? Do you have a way that you could interpret that or like verbally help explain what that...
The x values, where do we start and...
Yeah, okay, so it's looking at the graph and saying at what values of x does the graph start and end, right? So for you, where does it look like it starts?
-5.
X values, right? This is where the graph starts, at -5 for x values. And then for every value here, we have a point. It's coming out either on top or bottom or maybe on the x-axis. And it continues till where?
To 4.
To 4. Okay, so the domain is you can plug anything in between -5 and 4. So we would write that with what? How?
Compound inequality.
How do you mean?
Like the -5 is, x is greater than or equal to.
Oh, okay, I see what you're saying. You're going to do like this. You could do this. -5, 4, like that. You could say that. That's perfectly fine. It's all, the domain is this. The domain of F is everything between -5 and 4, right? Using intervals, you could go -5 to 4, like that. But this time, we have to have brackets. And the brackets are because at -5, you actually have a point, right? And at 4, you have a point. Either one of those would be okay. Good. Everyone understand that? Okay, G, let's go to H. What about this? Ran F. So I've never shown you this one before, I don't think. Ran is the range, okay? What is your name? Cecilia. You doing all right? Okay. So do you know what the range is? What that represents?
Yeah, it's the Y value.
The Y values, right? The outputs of the function, what do they range from? Between where and where, right? So what do you see from the graph? What does it look like to you?
That it starts at 2 and ends at -2.
So from here to here, right? From here to here. For -2, there's a graph that comes down to -2, right? And then it goes all the way up. You have every value in between, don't you? All the way up to 2. Okay, so I would say that, and I need to do it again. I'll do it with intervals. And when we do it, we would not do 2, -2. We go in the order in which it would appear bottom to top. Just like on x-axis, we go left to right. For range, we go bottom to top. So -2 to, what, 2? How is that? Okay? All right. Why is this not going to go in here? There we go. Jesus. Okay, I'm going to give you one. I'm going to have you work on it. So you'll want to take a little bit of time to write this one down and like draw it with some precision. I'm going to turn the projector back on so it'll be easier for me to put it up here. Okay, here we go. Kind of glad this is kind of a nicer section to have our first day face to face with. It's friendly, I think, I hope. So all I'm going to use this for is just a graph to draw on, okay? I'm just going to go right, I'm going to draw on the board. All right, so let me draw this first. Again, don't worry too much about being precise because you're going to be able to look at this